Hello, and thank you for joining Game of Stones podcast. This is our series on shop information, and today I wanted to cover the topic of air and how there's a few things that you could do to make your life better when it comes to the discussion of air compressors. And so I prefer the screw compressor, right? Screw compressors, they're less maintenance, less noise, just easier to maintain. And so most shops I see, they have screw compressors. And so the rule of thumb is the screw compressor, each horsepower should give you, what's important to think about here is CFM. And so the screw compressor, 25 horse, will approximately give you about 100 CFM of air pressure. That's consumption or volume per 125 or at 125 to 135 PSI. And so what I see happen a lot in shops, and just by being in many shops, possibly almost 1,000 different shops in my career, I've noticed that the specs on the hand polishing tools are overlooked sometimes. And so these hand polishers are being fed with lines that are directly going to them from the screw compressor, which is set at 125 PSI. Now, most air polishing tools, their actual specs on average are about 85 to 90 PSI at a CFM of about, that'll draw about 20 cubic feet per minute, so 20 CFM. And so these hand polishing tools, they're getting a direct, not 85 or 90 PSI, which is what they need. They're getting 125 to 135 PSI. What does that mean? That means that the CFM consumption is greater. In other words, each tool now is approximately pulling, instead of 20 CFM, 28 to 33, 34 CFM. So that means that really a 25 horsepower screw compressor should be able to feed easily 5 guys. Kind of like the burger joint, right? 5 guys. So the 5 guys should be able to draw easily off of that 125 horsepower screw compressor. But what's happening instead is that it's getting bogged down because only really it can supply 3 people that are using this hand polishing tool, which is taking an enormous amount of CFM. And so the other thing is that there's a vast fluctuation, which isn't normal for an air tool. So when an air tool gets some kind of PSI, for example, an edge machine, the edge machine will push the abrasive slowly to the granite and it pulls a little bit of air. What happens with these hand polishing tools is as the operators are exerting pressure on the granite, it creates a push-pull situation with the airflow and the capacity into the air tank. And this is happening over 3 or 4 or 5 different people pushing and pulling. You're having a lot of fluctuation in that air system. And those fluctuations, if they're tied to the same system that's feeding a Venturi vacuum system for vacuum lifters, or for instance, something that is very sensitive because it takes or needs low CFM, such as a backsplash polisher or a bullnose edge machine or a CNC router or a bridge saw or a CNC saw, that maybe some CNC saws are using the air for the vacuum. Others are using it on a rotating table for the air brake, the air clamp. Either way, an edge machine CFM is approximately 6 or 7. Now, if you are polishing with a polisher at 125 PSI, and this is taking 33, this is taking 5, the air needed to feed 5 backsplash machines, okay? The CFM needed for also the tables of the bridge saws for their locking mechanisms is about 5 or 6 CFM. The CFM needed for instance, a Venturi system like the vacuum pump on a T-Rex machine by Poseidon, you're going to need at least 15 to 22 CFM for each table. And so when you look at that CFM comparison, all of them are much less, and they don't have fluctuations that are constant. They're much less than a collective group of hand polishing tools, especially if they're ran at the incorrect PSI. And so the best way to curtail issues and not have, because when you're constantly running at a higher PSI and a higher CFM, you're pulling constantly air out of the tank, which means you're making both compressors if they're tied into tandem. Because most shops, what they'll do is they'll tie two screw compressor sets together as if they're one system. Because this is recommended, and this is the right way to work on 99% of other applications except for a stone shop. Because you're providing air for pretty much very fixed air applications. For example, in wood, you don't have an air polishing situation with guys pulling on air polishers. You have pretty much all different types of machinery that take a consistent low CFM air intake. And so it makes sense to tie two compressors again when you're doing that kind of shop operation. But not for a stone shop because of the high CFM and push and pull application of the tool when you're doing hand polishing. So my recommendation is split two compressor systems apart, completely independent from each other. If the one for the hand tools, you want to leave a backup compressor or backup compressor that has a T that can help augment one system or another in case of fail, but that it's not automatic in tandem because that isn't a good situation. I would recommend having two separate screw compressors, one only for the air polishing tools. And number two, have a different screw compressor only for machinery and vacuum lifters. You'll find that you'll have a lot less air issues. You'll have a lot less maintenance. Your electricity will go down as well. And then the other very important thing is to make sure that there is a step down regulator from 125 or 135 PSI to 85 or 90 PSI to some kind of manifold where you can feed the correct PSI to what the hand polishers require so that your compressor will work less hard. And that will help you tremendously. So those two things, separate screw compressor system for just the hand tools, screw compressor system for just your machinery, a 25 horse or 30 horse here, and you can have easily a 20 to 25 horse here to feed 4 or 5 different types of machines. Make sure your dryers are dry. Make sure that you have proper maintenance on your screw compressor to make sure that there's no humidity in the air lines and that you also have no low oil levels that can cause overheating, etc. And that's pretty much it. A good resource for getting these components like manifolds and fittings and air tubing and things like that and step-down regulators is McMaster Car. I believe the website is mcmaster.com. And so you can just look up in Google McMaster Car. They're a great resource. They have everything in imperial and also in metric. And a lot of these machines and machine parts come from Europe, so they're going to be in the metrics. So that'll be very helpful for you. And thank you very, very much for joining us today, and I hope that this was useful for you. Thank you so much. My name is Joe Alva with Poseidon Industries.